All right, welcome to ETE 130. This is Zachary Shibley and Paul Prey, and today we are doing a mod 10 binary bit counter. So we've got these 4 LEDs flashing once per second, and you see how this would be your 8-bit, this is your 4-bit, your 2-bit, and your 1-bit, and once the 8 and the 2 add together, resets. So basically how this works is we've got 4 JK flip-flops in here. And this would be our 1, this is our 2, this is our 4, and this is our 8. And we've got all of these going to resistors into LEDs. So when this one triggers, it will go to this one, and then once these 2 trigger, it'll go to this one, and once these 3 trigger, it'll go to this one. So, and the way we have this is when it adds up to 10 with the 2 and the 8, it goes to a NAND chip that is up here. And this will reset. It goes to all of the resets on these chips, and it'll start back at 0. So we've got a couple calculations. We've got our voltage drops across our 390 ohm resistors. We've got the 5 volts minus the 1.8, which is what the LED is dropping. So we've got 3.2 volts across all of these resistors. So our cycle time is 0.5 seconds because we're dealing with 20 hertz here. And we're counting to 10. So we have our 10 count over our 20 hertz is going to get us 0.5 seconds for the 20 hertz to count all the way to 10 and then reset. So, and then for our reel, which is on our circuit, it's going once per second. So we've got our 10 count over 1 hertz, so it will count to 10 and then reset at 10 seconds. So that's how it's working. We've got our toggle switch here, so this will just reset it. So it'll just start counting it back at 1. So that's how that works. So we had a little bit of troubleshooting that we had to do, and Paul is going to explain how that went.
So when I actually came up to the circuit, it was only half built, but that was just the start. So after we went through and we wired up the circuit to the diagram that we were given, then for whatever reason it was turning off once the bit got to 8. So it was acting like a mod 8. So the problem seemed like it was around like the NAND chip, or maybe the way the LEDs were hooked up. We weren't really sure at that point. The things that could cause it is if we set up wiring wrong, if there was loose or bad wires or connections. The chip could have been bad, there could have been floating inputs. LED, the one that wasn't turning on, could have been loose. There could have been a bad ground, bad power, or there could have been a short somewhere in the circuit. So what we noticed was the actual cause happened to be a wire connected to the 4th reset. We found this by pretty much disconnecting the NAND chip and seeing if the normal 4-bit counter was going to work, and it didn't. So we knew that it was actually something before the NAND chip. And so after we looked around the circuit, we unplugged different outputs between the chips, and we made sure all the circuit was good. We actually found it was a problem with the 4th LED. No matter what we had, it wouldn't turn on. So pretty much we checked the LED, and we pretty much couldn't. We tried plugging it in, like checking all the power and everything. It wasn't turning on, so we plugged it directly into 5 volts, and it did pop on. So we knew it wasn't a bad LED. And then so something seemed like it was going on maybe with the reset going off, because there was no signal coming through that Q input to go to the light. So we hooked up the NAND chip with them again, but it was separate so that we could actually test all the bits together. We tested the first one with the 2nd, 3rd, and 4th, the 2nd with the 3rd and 4th, and then just the 3rd and 4th. And they all actually ended up working through the NAND separately from the bit counter circuit. So we knew that the NAND chip was working as well, and so we hooked it all back together, and it was still happening until we actually replaced the actual reset on that LED, the actual wire seemed to be bad, and it didn't seem like it was going to work, so we swapped it out and it started working again, or it actually just started working. And then Zach actually borrowed his NAND chip to a fellow classmate, and during that time we had pulled out this 10K resistor over here that's pulling down all the resets as well as the output from the NAND, and we plugged it back in and the circuit was just counting through 16 even with the NAND hooked up. And it was a little confusing at first until we actually then put the 10K resistor back in and the issue was resolved. So that is our practical 3 lab with Zachary Schiebel and Paul Prey. Thanks.